Before you start using variable selection techniques, I just wanted to give you a few words of caution. Overfitting is still a possibility even when you use a variable selection technique. Maybe you still leave in a few variables that really aren't contributing. Underfitting is also a possibility. Maybe we remove too many variables when they were actually contributing. The add and remove decisions in variable selection techniques are very subjective. I've given you my rule of thumb that a variable should contribute 1 or 2% at least to an R-squared metric, for example. But that's very, very subjective. Different people would say different things. Some people would keep a variable that only contributed 0.5%, and some would say, oh, I want to see at least 5% from a variable. So I'm just giving you a place to start. 1 or 2% is reasonable guideline, but again, it's a subjective decision. Be sure to incorporate your intuition when you're making these decisions and not just the calculations. Your intuition might say, this variable really doesn't belong, or I'm pretty confident that this variable is telling a story, and make sure to incorporate that. One thing you can always rely on when you're creating a model to tell you if you've overfit is cross-validation. This is the process of dividing into training and testing data and comparing your performance in both sets. If you have great performance in the training set, but poor performance in the test set, it probably means you added too many variables and over-customized the model specific to the training set. This is a clear indication of overfitting. Even if you don't see that, you still might have some variables that aren't really pulling their weight and could be removed. But at least we can always rely on stability and accuracy to tell us how our model is really doing. When you make decisions about a linear regression model, you can rely on R-squared or other fit metrics. And when you talk about logistic regression, you can make these variable selection decisions with fit statistics like the AIC that we talked about in the logistic regression videos, or you can use prediction accuracy. What I love about prediction accuracy is that you can always rely on it to tell the truth, especially if you're cross-validating. Finally, always keep the model as simple as possible and as complicated as necessary. You have to know your audience and your goals. You wouldn't want to present to a relatively non-technical audience a super complicated model because you want to be sure that your message is getting across. However, if the audience is really just you and your manager and you want to do a great job at predicting, then you could add complex terms like we're going to learn about soon, interactions and nonlinear relationships, just because you want good prediction accuracy. So it depends on what kind of problem you're solving and who you're solving it for, what the purposes are, how complicated your model should be. So it's important to keep in mind all of these things as you go through the process of selecting the variables to include in your model.